Well, I want to welcome everyone to course number 5 in our winter webinar series, Pumping Cement. Have a lot of good colleagues on board tonight. Looking forward to asking you a lot of questions. And the key word for the night is going to be concerns. The webinar is Pumping Cement. We're going to look at cementing operations. But while we do that, we're going to look at your concerns. When you walk onto a location, what are you concerned about? I'm going to start out talking about some things where I think you're not concerned and maybe you should be. Then we're going to move to concerns for 4 different aspects of pumping cement. And I think as I ask you questions about your concerns, I think you'll agree we all have similar concerns about the big things when we go out and pump a cement job. I'm going to be pulling up the chat feature. We're going to be talking a lot tonight. So thanks again for joining us. Those of you who are watching by video of the recording that we're making, then when I ask you the questions, pretend that when you answer, I'm actually hearing you. That'll make you feel more involved because I'll be asking a lot of questions. It's kind of like not made for TV webinars, if you know what I mean. So we will begin pumping cement operational concerns. Welcome. To start, I will remind you that in the chat feature, as we talk tonight, choose all panelists and attendees, and that way everyone can see your comments. In the 2 sessions that we had earlier, we have experts online and they answer so many questions. So it's good if you will change, instead of to all panelists, change to all panelists and attendees, and then everyone can see that. Also, I think we've had about 70 plus countries represented today. Pretty amazing and wonderful. So if you can tell me which country you're based in, and then your name and a big yes if you would like an e-certificate, which will be sent to you. If you're watching by video, we will just let us know and we'll be sending you a certificate as well. Feel free to do that. Because we're going to go for it for 90 minutes. You're dedicated to it. So many good colleagues and friends are back. And so let's begin. I see Mahmoud in Australia. The basic cementing operation. This will be maybe the only slide on basics. Although throughout the webinar, we're going to touch on basics and then more cutting edge advanced, some simple concepts, some more difficult, unique things that go on in operations. Of course, we prepare for the cement job and we're going to talk about the very first steps of a cement job and the preparation that goes into it. But when we get to location with the cementing unit, we're usually, hopefully, almost ready to cement. We're on bottom with casing or we're running casing. When we get to bottom, we're going to circulate the hole down the casing, up the annulus with drilling fluid. Once we condition the hole, get at least bottoms up or more, but circulate the hole very well, we're going to pump spacer. We're going to drop a bottom plug. We're going to follow that with our cement or cements, drop a top plug. We'll displace all of the cement out of the casing into the annulus. We'll do that with mud or water, leaving mud or water inside the casing and cement outside the casing, hopefully providing a barrier once it sets up so that we can then nipple down BOPs after the cement is set and then can either drill ahead or get ready to complete the well. A quick advertisement. Mahmoud, you're in Australia. I don't know how easily you can get to Lafayette, Louisiana on May 10th, but if you're nearby, we're having a 3.5 day. We start on a Monday night and we go for about 4 days for the Thuraban cementing course. Here's the key thing about this course. You can go and you can take cementing courses, or we can do webinars and we can learn information or discuss information, we do something a little focused here in the course. Before you arrive, whether you work for a service company or whether you're a student or whether you work for an oil company, you do some preparation work for the challenges that you have in your area or that you're dealing with. Throughout the course, you're building a presentation of an action plan of how you're going to address that. So you get to go to the cementing course, be coached by expertise to address your specific challenges, and then go back and present to your company ideas of how to make your cementing more effective and more cost efficient. That's just part of it. Uh, we also do hands-on, out on equipment in the lab. We have some friendly competitions, some major celebrations. So we're going to do it. We're going to do it. We have several registered, and if you can make it, we're actually working with some international participants, and it looks like they're getting over as well. So contact Jillian at support@thuraban.com. I start with the quiz, and so I'm going to ask you this. I'm very interested to see how you answer. Some time ago, we nominated Natalie as being really the cementing representative to the United Nations. She knew all the geographic areas, and so she is the expert. We've come to agree. So we're interested, Natalie, to see how you're going to answer these, because we have a lightning round of questions here, and I just want to see how many you get right. So because I can't see everybody's answer, so we're going to see how you do. First of all, cementing operations are usually day jobs or night jobs. I'll be looking at everyone's answers, but okay. Nicole, if we were playing Jeopardy, Nicole was first in with the answer. I think it's funny, someone posted on LinkedIn a picture of a cement job during the day, and everyone, of course, was saying that that was such an anomaly that it was during the day. I like someone's comment was, the only time you have a day cementing job is when something went wrong the night before on the cementing job, so that no one has slept for the day job. But yeah, I think about 80%, someone today said 99%, but I think about 80% of jobs occur at night. One reason is that it's night quite a bit. I think about half the time. So anyway, you got the first one right, even though I'm not sure there are any right or wrong answers. Next one, cementing operations are usually safe or dangerous? I have to don my glasses to see these answers. Elvis has a night job with rain on a weekend, don't forget. Natalie is hedging her bets. Should be safe, but there's a lot of pressure involved, which sounds dangerous to me. We do carry out many safe operations, obviously, but the operation itself, we approach with caution because it is dangerous. Next question, fast answers. Cementing operations are usually successful or unsuccessful? Natalie, you cannot say that they're supposed to be successful, but sometimes they're unsuccessful. We need an answer. Okay. Many people writing successful, I would agree. When we gauge cementing operations, if we didn't have above 95% successful operations in a region, that was not good. Having said that, sometimes you can have a great operation, but the well or the patient will die or still be injured. So the operation can go well, but when we run a log or when we see zonal isolation, maybe not so quickly do we say it's a success. But usually they are successful. That's good, But at the same time, we can become complacent. And we'll be talking about a few concepts. The first one is, what are your concerns? The second one is to pay attention to the details. And if you get 4 jobs that went pretty easy, you think, oh, this is easy. We don't need to worry so much anymore. And that's when the failure will come and see you. Okay, so far our ambassador is doing quite well. Cementing operations are usually simple or complex. Simple or complex? Are we sure? There are no right or wrong answers. But when you throw in the fact that we're dealing with the mechanical equipment, we're dealing with the chemistry, hydraulics, the engineering aspect alone, now we have all of the moving parts that you will see. It's a very complex operation. When I was preparing for this webinar, we could do a 6-month webinar on operations. There is so much to choose from. It was difficult for me to determine what to focus on because this operation is complex. We're going to show some simplicity tonight, except it is complex. Usually. Cementing operations are usually similar or different as you go around the world. Vahid says different. Natalie goes with different. Not only are they different, they can be very different. I've had the opportunity, I was looking to how many countries have I been on a cement job in? And it's a chance for those of you who don't know me, who haven't attended a webinar. My name is Kirk Harris. I worked for Halliburton for 23 years. I then went to work for Occidental Petroleum as their global advisor, and then Talisman and Repsol as their global cementing advisor. I now consult in bond log interpretation, cementing consulting, a little bit of training in product development with our company Thuraban. And we get on and talk every few weeks on our regular webinars. But when I started with Halliburton, I started as an engineer in training, but I quickly became a cementer and went out and used the equipment and cemented wells. I'm not speaking today from a theoretical standpoint. And I was thinking as I went around the world, how many different countries that I cemented in or was on location supervising cementing operations. And although I've engineered in more than 40, 50 countries, I've been on site in about 15 countries, from remote jungles or remote geothermal wells in northern Sumatra to deep water in Indonesia or deep water in the Gulf of Mexico, to downtown Los Angeles, cementing wells in the middle of a city. Where you go around the world, from the Bass Strait of Australia to the West Texas area, it is different. That's so important, and we're going to talk about that. The local practices that are very important. As a global advisor, we put out global best practices. Those have to be refined and targeted for areas to get good cementing operations. So they're very different. So I'm anxious to hear tonight some thoughts that you have about how you do cementing operations in your area. And finally, cementing operations are usually from place to place. Are they getting better or getting worse? Okay. Natalie says better. And we're going to have to believe her. I hope they are. I hope they are. Again, from area to area, Both service company and operator do things differently. Some are better, some are worse. But generally speaking, with new technologies, with lessons learned, hopefully we're getting better. Well, thank you for taking that quiz. The agenda for tonight, I'm going to give a short introduction about concerns. Concerns that maybe you haven't thought of. I think about these. And then some maybe you have thought of. I want to talk about 4 areas of pumping cement. And the concerns that you have, we'll talk a little general knowledge about each of these areas. And we'll talk about the concerns and focused on these major concerns. The first will be for the cement slurry. The mixing of the slurry, the preparation of the slurry. On location, we want a quality slurry to be pumped down hole. Be thinking about what are my concerns when I go to a location about the slurry. Then we'll talk about the plugs. We pump slurry, they're usually preceded and followed by plugs. And there's a whole lot of things around the plugs that may give us concern. The equipment. We place that slurry at high pressures and displace it at high pressures. We use a variety of equipment, both on and off location for the operation. As we prepare and as we go to location, what are your concerns about equipment? And then finally, an area that I like to spend time with. Boy, I've got a terrible story to tell about the most recent cement job I was on and about the returns. I'll just say in short, we got a lot of cement in the mud tanks, and that's not good. We brought the expert on location so we could fill a mud tank with cement. I'm going to make this story very short, and maybe throughout the webinar, I'll even forget to tell it, and that will be good. But what are your concerns about the returns besides pumping that cement into the mud tank? Another question. In a line or two, what separates a good operation from a bad operation? We're thinking cementing. My other passion is horse racing. I train race horses, and I've talked about this quite often of what is the difference between a good horse racing operation and a poor horse racing operation. The same, I see it with cementing operation. In a line or two, in a word or two, what separates a good operation from a bad operation? I'm looking for the answers. And I hope you're joining me with your cup of coffee. You know, as an aside, I was watching someone give a presentation on TV the other day and they kept drinking their coffee. And it actually annoyed me a little bit. And I thought, maybe I better stop drinking coffee. And so I didn't drink coffee this morning. And someone said, we want to see you drink coffee. So I'm going to drink my coffee, but I realize that it may annoy someone because if I were you, it would annoy me. And I'm giving you the chance to answer the question while I sip my coffee. Okay, now it says to provide zone isolation. Yes, but as a company, just as a company, getting out there and being able to pump the cement to do that. When I think of a good operation, I'm really thinking of a company that comes out and does the cementing. And I will tell you, from the big service companies to the small service companies, it varies from crew to crew. It really varies from region to region or operation to operation. You can have a big service company that has a very good operation in one location and not so good in the other. It's not like going to McDonald's where you get the same thing no matter what. Communication, what else? What separates a good operation from a bad operation? Ooh, Jacob, I like that. Personnel that care. I like that. Okay, thanks, Natalie. Evaluation of the well bore. Knowing the well. What else? If you had a cementing service company, what would make your operation that you go out and do a cementing job, that cementing operation was a good operation? Okay, thanks. Risk assessment. That is a popular word, and I agree with it completely, Gary. And that is preparing or planning. Spending the time. I have a saying as providing service, and that is time is everything. Time with a client is everything, is kind of a saying I've got. Good equipment. Doesn't have to be the newest, although I quiz people today. Do you like to see new equipment or painted equipment, or what if it's old and a bit rusty? No one likes it old and a bit rusty, but well-maintained equipment. I guess if it's rusty, maybe it's not maintained. Great, and that's a great answer. For the service company, let me throw a few up here, but my sentence is, over everything is attention to detail. Whether it's the planning or the equipment maintenance, it's having detail. You know, in the horse racing business, you can do about 50 things every day to take care of that horse, or you can throw some hay, and some operations just throw some hay and say, I hope you run fast next time. Attention to detail is everything. For the service company, it was mentioned, and I'll go through these very quickly, but it's good people. It is good equipment. It is good standard operating procedures, hopefully in conjunction with the local oil company or the oil company with the local operation. It is managed well. If it's not managed, all of those things fall apart. And here's one, good competition. I found when I worked for the service company, if we didn't have competition, if we had all of the work for a client, after a while, we got a little complacent and we'd go be fighting for other market share, but we'd be a little complacent until we might be threatened. You better get better or we're going to take you off the rigs. Competition is good for the cementing company. For the oil company, this to me is the most important thing. I have a document here from an operation in one region of how in a field we're going to cement. I don't know how many pages I have here, but these are detailed plans, 30 pages for cementing one well. Attention to detail. In this particular location, working with the service company, the oil company, and this was one of the oil companies I was working for, absolutely outstanding work. Local cementing procedures and the field people trained to know what we're doing and why we're doing it. It's very important. I was on a job recently and we went to put our first centralizer on as we ran the casing, and centralization is important. We found out that we had no stop collars. The stop collar is what you will clamp to the pipe, and you will put a centralizer over that stop collar so that when you go in the hole, you're pulling the centralizer in the hole. The stop collar would not fit that they had. They had the wrong stop collars out on the rig. So now we have no stop collars. So we have the centralizer and someone yelled to the company man, hey, we don't have, the stop collars aren't working. What do we do with the centralizer? What do you think his response was? It's important. It's crunch time. What do we do with that centralizer? And we had to step in, but he said, just put it on and let it float, a bowspring centralizer. That's not good. We don't want to push that centralizer into the hole. If anything, we're going to put it around the collar, or we're going to we had some other options for a stop collar. So we actually did some things and did find a stop collar and put it on. But very quickly, we can not understand that centralizer doesn't need to be floating. Here's another one. How about this one for the oil company? Now remember, I work for service companies, but I've worked for oil companies. So I've had to tender to get work. I've also had to put out multi-million-dollar tenders and supervise those. Use two service companies, again, with the competition. Some places you can't. Some places are remote. Some places are a huge operation where only one infrastructure of service can be built. But if you can, use two service companies. A bit controversial. I like competition. Here's one. On a tender, you should know what the cementing service should cost, what a fair price is, what a reasonable price is, so that it's a fair price, but that the service company is making money, is gaining a profit. Trust me, I've been through this over and over. If a service company is not making profit, your service will start going down, probably start going down pretty quickly. Therefore, we would put in, if you don't bid at least this much, and they don't know what that number is, but if you're too cheap, you're not going to get the work. We don't want anyone to come in, not be able to survive, and watch our services go down. A couple controversial thoughts. Those are concerns that I have that maybe you haven't thought about from an operational standpoint, a big picture standpoint. We'll now look at other concerns, starting with the slurry. We want a quality slurry pumped down hole. So I ask you, what are your top concerns when it comes to the cement slurry? What are your top concerns? I actually got a little angry this morning because no one was telling me the truth. Now here's how I want you to answer the question. You go on location, you're going to do the cement job, and for a minute, I want you to think nothing except about this cement slurry that we're going to mix. We want it to be high quality. So what are your concerns with that? These concerns usually aren't spoken. I don't know, maybe we're too cool on location. I don't know. Some of these concerns we don't speak, but we're all thinking it. What are you thinking about the slurry? Natalie hits the first one. Can it be mixed? Jacob's thinking, am I going to be able to get this cement put away? I'm thinking thickening time. I know it has to, pardon the pun, flash through Jacob's mind. I hope this cement doesn't flash set. But can we mix it? Is it too thick? I've been on many jobs where it's too thick. What we mix in the lab is easier to mix in the lab than it is in the field. In the lab, we put in 1 API mixing energy. That's based upon the old high pressure equipment where we used to pump at 1,000 PSI through a choke to mix the cement. We now in the field with low pressure mixers probably mix at about, on average, half of that mixing energy. It's easier to mix in the lab than it is in the field. Another reason why I like thin cements. We'll talk about water quality. Good point. Mixing properly. Here's the other thing. Can I maintain density? Not is it too thick, but can I get density and keep it? It's usually not a problem that the cementer is going, wow, I just can hardly control this density. It's always too high. That's not the problem. The problem is my density is too low. So I have to slow down and let my density get higher before I pump it away. Is it too thin? And if it is, it means we're not getting the cement part of the equation into the mixer. It's one of the biggest problems, and we'll talk about it, and that is delivery of cement from the bulk truck to the cementing unit. Natalie's thinking a little bit differently. She's saying, will it achieve the required compressive strength? Others are thinking, we don't care, Natalie. We want to pump this and bump it. I don't care if it ever gets hard as long as we get it placed. But Natalie, you're thinking correctly, but will it flash set? That's our concern. At the very end of the webinar, I'll show you 10. We'll add 11 experiences I've had. I'd like to hear some of your experiences on flash setting cement. So as we address the slurry and the big concerns, it starts here. It starts with the cement blend, then we look at the mixing water, the delivery, and then we'll talk about continuous versus batch mixing. But it does start here. It starts here, far from location, in a place near and dear to my heart. It is the bulk barn. This is where I started. This was my first duty when I started for Halliburton. My first job was to cut sacks of additives, put them in the hopper, open the valve, and allow the vacuum to put them and layer them on top of cement in the scale tank as I prepared the blend to go to location. Here we have preparing the blend into the hopper. This is a super sack. I think it's 1,000 pounds of hollow spheres, cenospheres, hollow pozzolanic spheres. You can see where it's made. Those go into the hopper. They're blown into a scale tank. We put the cement into the scale tank. We layer cement, then additives, cement, additives, cement into the scale tank. We weigh it out. We then blow it back and forth. 1, 2, 3, and 4 goes to the truck. We'll have to do this several times to fill a truck or on location to fill a silo. While we're doing that, as it goes to the truck, we're going to catch a sample. We have an automatic sampler that takes the sample out of the middle of the stream of cement as it pneumatically flows, is pneumatically transferred to the truck. On this particular day, actually, the sampler was not working. I don't know how long it had not been working. And so there's a ball valve there where you may be catching a sample, representative or not, it's a sample. And we're going to take that sample in a plastic bag and we're going to store it and keep an eye on it. And we're going to take some of that and run a blend test. When we run a blend test, I'm not sure how you run it, but I know a blend test all over the world is run differently because it is some task to test every single batch because it takes several to fill a truck or a bin. Sometimes we sample every one and test every one. I know some operations that do that, and it is attention to detail, but boy, is it a lot of work. And it ties up the lab issues with that. You can take it from just one load. I don't know what good that does you. It does you some good, but one load, you take the sample, you could mess up all the other loads and it'd be a disaster and you'd never know it. That's happened to me before. Or you can take a little bit from each load and do a composite blend test. Often we'll do thickening time tests, so we're talking more than 4 hours where we're waiting. The bulk truck sits in the yard. We've had in busy times, we've had traffic jams in the yard because we're just waiting on blend tests, causing all sorts of logistics troubles. Or some service companies had the idea, I don't know if it's good or bad, to be honest, and that is send the truck to location, and we also send liquid retarder, and we make sure that we will design with not enough retarder, and then we'll add liquid retarder and adjust it during our blend test. I know one region that does that all the time. They sell a lot of liquid retarder. I think they run a lot of liquid retarder. That's my concern. Think about this one. This is an easy way to test everything you load into the truck, and then you can do it very quickly. This is done by some service companies, namely Baker was doing this in southern Argentina. And they just know the slurry, what it looks like when they're mixing it. So when they get a blend, all they have to do is mix it up and see what the viscosity is. Often when you have something wrong, it will show up in the viscosity. So they mix it, and you can tell on the right what's a pretty good cement. The blend test, we're getting all sorts of lumps and problems. So we know something's wrong and we can check it out there. And then we run a surface rheology at ambient conditions, and we compare with the pilot test, the blend test. That way it's simple, it's easy, and we test everything. That may not work for your region, and you would have to learn what works best for you and how you can manage operations. But cement blend testing and preparing that cement blend to go to location is very important. For offshore, after we cemented up all of the drill pipe on a job for a major company, we opted to this kind of frame. Everything over 125, we will do a blend test for thickening time. And we need to gather that either as we transfer to the boat or as we go out and get the cement, bring the cement in from the rig. Because sometimes the cement's sitting out there for a long time and it can cause some big problems. Understand again, we do it differently everywhere. In the Gulf of Mexico, we will have dry additives and liquid additives, but a lot of dry additives mixed in the cement that goes onto the boat at times. In the North Sea, all around the world, mainly the only blends we put out there are silica flour blends. And then we have neat cement, and all additives that we use are in liquid form. The mixed water, someone mentioned that. Once again, it's very local. In the north, in cold weather, we have to heat the water. Cold water makes very viscous, difficult to mix cement. I put 70 to 80 degrees for one region. We had it narrowed. We're going to heat the water between 70 and 75. In West Texas in the summer, some people use less than 90. I'll use less than 95. We don't want the water to be too hot. We did a major study which showed that it only affects accelerated slurries. So if you have a slurry with retarder, the water can be hotter than that and you're okay. You don't have to shut down the job, but water temperature is the main concern. We test chlorides, we want them less than 3,000. Above that, we see the acceleration of the cement. We'll check pH, we'll check specific gravity, dissolved solids, sulfates, and some other properties as well. From region to region, we test different things. But these are the main ones. I'm going to skip, but we are doing calculations. We are looking at our operational procedures. I hope they are more detailed, and I hope they're a partnership between the operator and the service company. We covered this in our first webinar, so I'm going to move through that, and let's go right to location. That bulk truck is now on location. We have our water truck there to the left, the black water truck. And I don't know who the blue is. There's a few blue companies, so you don't know who this is. You'll notice that we have a ball valve and we're transferring pneumatically the cement through the hose to the cement truck. We're going to take a sample here as well. We're on a job where we're supposed to mix the cement at 16.4 ppg. On location, we couldn't get above 14 ppg. We had to abandon the job, and fortunately, we took a sample of the cement from the ball valve. When we got the sample, it was brought into a lab in New Mexico, and I looked at the sample and I said, wow, this isn't our cement. It had lost circulation material in it. We didn't order lost circulation material. And it was very evident to see little pieces of plastic were in the cement. So we went and said, you loaded the wrong cement. And they said, no, we did not. Here's our cement that we loaded. I said, well, you had contamination in your truck. No, we did not. We checked it. It was clean. And I believed them. Where did the lost circulation material come from? Where did it come from? That's a question. Where would it come from? Can you take a guess? The point of this story is that anything can happen. If you haven't seen it, you will if you keep going to cement jobs. Ooh, interesting. I never thought of that. Although I had a water truck one time, and as we unloaded the water in the displacement tanks, there were shredded carpeting was in the water. It was a total mess. But this was in the dry sample from the ball valve, had LCM in it. That's what we thought. That was not the case, Natalie. Natalie says contamination of the cement from the previous slurry that was in that bulk truck. They blew it down and had that truck clean. I believe they did. I won't take too long with the story, but we started investigating, and finally we had an honest bulk truck driver, and he told us the story. I felt so sorry for him. I hope they promoted him and gave him a raise, because for him to be honest about this, I felt very sorry for him. He went to the wrong location with the bulk truck, and he blew the cement into a cement bin on that location. He then, I think people were looking at him going, what are you doing blowing cement? We've already done the cement job on this location. He was told, or he realized he was on the wrong location. So he blew the cement back into his truck and went to location. What he didn't know was the pot that he put the cement in had a lightweight cement with bentonite and lost circulation material in it. And so he contaminated the cement on the way to the rig. Can you believe that? An amazing world of cementing we live in. That's why we need to sample on location. That's one reason why. Some service companies have taken away the valves to sample. So if nothing else, reach in and grab some out of the line, get some evidence just in case things happen. Here's where the cement goes to. There, the valve on the left up there, you see dry cement going in. For all of those big red fans, this is not a Halliburton cement head. This is a different company. Dry cement goes in, you see the H2O. It will be in a jet form, either kind of axial or rotating, and it will wet the cement and it will fall into the mixing tub. Here's where the energy occurs. It then goes into a containment and it is recirculated. So you see the slurry coming back in. So all at one time, you have dry cement, you have water jet, and you have recirculated slurry. And we end up with the mixing tub. I'm not saying this is pretty cement, but it is gray. On the left side over here, that's the pre-mix side. This is where we're going downhole. We have agitation. And this is where we look and see, is that quality slurry, can it be mixed or is it too thin? If you ever have a thermometer as well, it's pretty handy. Check sometimes, you can kind of touch it, be careful, kind of touch the cement to see if it's warm. I've been on operations where we've pumped some very hot cements and I've been very curious about that. Here we are mixing some more cement. This is pretty close to downtown Los Angeles. We're mixing cement here in the tub. We're going to confirm density. Once again, the last job I was on, we did not confirm density. I was going a little crazy. But at the beginning, in the middle, at the end of a continuous mix, we'll check the density. It's easy to get the cement up to density, check it. We calibrate our densometer at that time and then just trust the densometer. But we want to see it at various points while we're mixing, confirming that our density is correct. We also check it electronically with the densometer. You can see here the density. We want it to be uniform. We're struggling. You can tell we're struggling with density because if you look at the pump rate in the blue there, we're dropping off the pump rate, trying to get density control. We're backing off the pumps. We then finally line it out. The cause for that so often is getting cement to the unit. And once you start having problems packing off, or you're having problems getting delivery, it continues as an issue. These bulk trailers have aeration pads on the bottom, and we fluff the cement. We aerate the cement before each job to get it to flow, but it can still pack off. You can still get surges of air, which cause problems. I think you can see a surge of air here, a surge of air. There are actually 4 people on this truck. I know, I took the picture. And in that dust is our night company man and the cementer. The other 2 gentlemen, one is an engineering advisor and the other is the day company man. But 2 people are coughing right now back there in the cement dust. To the right is our bulk bin or bulk cement, and we have someone tending that, tending the bulk truck, the bulk driver. What is he doing during the job? What is he continuously doing? Someone this morning said taking it easy, but he is not taking it easy. What is he doing? He will be opening and closing the valves as we go from pod to pod of cement or from silo to silo. What else is he doing continuously? It's a skill. I don't think I'm good at this skill. What is he doing? I'll give you a few seconds to answer. He is opening and closing valves, but what else is he doing? If you're on the cement job watching him, we have a compressor that's running continuously, keeping a constant pressure. He's looking at that pressure. That pressure will tell him some things. So thank you, Natalie. But he's doing something. He's doing 2 things, actually. And he's making hand signals as well. He's talking to the cementer. What is he talking about? There you go, Natalie. He's hammering the bulk tank. He's got a rubber mallet and he's hitting on the containment. And he's checking, as Natalie has just stated, he's checking the cement level. How much cement do we have left? In this case, as we go to the end of the job, it becomes very important because what will happen is he's checking the level and suddenly we're out of cement, but we already know it on the unit because we're now getting air and our density is dropping quickly and we get a lot of dusting. It happened on a couple jobs ago. It happened to us and I don't like it because we now have an entire 8-barrel tub that is low density and we pump it down hole quite often. So as we're checking this cement, be ready to shut that water off. The last part of your cement should be heavier, not lighter. And quite often when we run out of cement, we're still mixing cement and we get a lower quality of cement at the end of the job. For those reasons, we often will batch mix. I work for someone right now and I agree with him because he's been on so many jobs and he cannot get a good continuous mixed job. Go back to whether things are getting better or worse. And so he will batch mix all tail cements and all critical cements. Batch mixing, instead of mixing on the fly where our retention is about 8 barrels, and as we're mixing, it's being pumped down hole. Batch mixing, we mix all of the cement before we start pumping it down hole. And we keep it in these containers. This is a 250-barrel containers or 100-barrel batch mixer. so we can mix. And here we have some beautiful cement in the batch mixer. I remember this job. This is actually beautiful cement being pumped in Oman. Now, what are some concerns about batch mixing? First of all, what is a good concern? What is good about batch mixing? Why do we love batch mixing? I know we don't have to worry about the way it mixes, but what does it give us? Natalie mentions considering or the effects of batch mixing on thickening time. We simulate it in the lab. I'm not sure it really counts so much as we simulate it in the lab. But what are we trying to get out of batch mixing? Exactly, we're trying to get a uniform constant density slurry. We don't worry about it here. It's a beautiful slurry. Let's pump it down whole. Much better control of the density. What is the concern about batch mixing that you need to be aware of? I don't know if for any of you, this is the first webinar you've attended, but you're saying, man, he asks a lot of questions. Doesn't he know anything? I know I ask a lot of questions. What are your concerns with batch mixing? The time it takes, that's a good point. We're on the clock. There's no messing around. We could be concerned about the viscosity of the fluid. Often on these, we have a centrifugal that is circulating this fluid while we have large paddles that are stirring the fluid. Here are some other concerns. These are good points. Here's a big one, and that is fast setting cement. I don't know how many batch mixers that I've been involved with that I've cemented up, but it's been quite a bit. I was sent a picture from the North Sea of a batch mixer with a cutting torch has taken off a side of the wall of the batch mixer, and carved in the cement were the initials of our field engineer. And so our field engineer sent it and said, thanks a lot for the design recommendation, Kirk. And here's a beautiful picture of a cemented up batch mixer. The problem is you can get friction and you get heat retention. Cements are exothermic reactions, but if you get some heat in the cement and you have a large mass, that can get pretty hot if you have an accelerated slurry or if friction is being involved. So heat retention in the large volumes, I don't think we mimic that well in the lab, is an issue. Large jobs, we have 100-barrel tanks. If you're going to put 2 or 3 batch mixers out there, the footprint and the cost are involved. So we usually use it only for small volumes of fluid. Although for the large volume jobs, we do this for hollow sphere cements. You can use it as an averaging tank. Fill up 50 barrels or 100 barrels of cement, pump that down hole. While you're pumping that down hole, you continuously mix into the batch mixer. So be careful with batch mixers. Once again, a thermometer is nice to have, but too many times we've pumped cement out of a batch mixer and it's getting hot, especially if we've had that mixing time extended. We'll move to the plugs. And my question to you, another question. What are your top concerns with cement plugs? Again, the big concerns when you go on location, when you're dropping plugs, we'll look very quickly here at the basics of dropping plugs, and then we'll look at some more cutting edge technology. What are your top concerns with the cement plugs? You're on location, you want things to go well, that you have the right plugs. Okay, the depth, where do I have to pump these plugs? But what are your top concerns? Usually my top concerns are what can go wrong. I want things to go right. What can go wrong here? That you have the right size of the plugs. Do I have the plugs on? Now listen, do we even have any plugs on location? That concern usually is quickly alleviated, but sounds like a bad experience there not having the plugs on location. Yeah, do I have the right plugs? I look at it this way. Will the bottom plug open? Was that bottom plug a top plug? If it's a top plug, we're in big trouble. If you ever have had, and I have, the bottom plug not open, I've had subsea release bottom plugs, and subsea release plugs are a whole nother issue. We'll look at that a little bit. We had a plug that was a non-oil resistant plug that we circulated while we were circulating the well. The oil is with that plug and it melted the plug. So when the bottom plug hit, it was just a ball of rubber that just slammed shut and the job was over. That job was in Vietnam. Will the bottom plug open? That's important. Will the top plug bump? If it doesn't bump, and we bump plugs about 88% of the time. We used to bump them more. Now we're a little more careful. If it doesn't bump, we still can get a good cement job. But no one feels good when the top plug doesn't bump. It could be a perfect job. And if we don't bump the plug, everyone is a little sad. Just a little bit until we tag the next day and find out where that cement is. Here's one of my concerns. I remember the first time I had to go up and stab a cement head about 25 feet up in an ice storm. I remember how long it took me to climb up the ladder with no safety harness. We didn't use safety harnesses there. We climbed up in the sky trying to stab difficult to stab cement heads. So I will say it maybe one more time. Maybe things are getting better in the cementing world. Used to be much more dangerous. But how much trouble will we have stabbing the cement head? Because after we circulate, sometimes we'll put the cement head on and circulate some more. Sometimes we won't. We'll get the cement head on and do the cement job. How long does it take? When I'm on location, I don't like being there waiting while we try to get this operation going while the mud is static. We want to circulate and very quickly then cement. Let's look at plugs very quickly. To the left is the top plug, a solid plug. To the right, usually red, not always. A little side bit of information. The color of the rubber is actually, I believe, red. We got to color them to make them black. I didn't know if you knew that. But the bottom plug, that top disc will burst. This particular plug at about 250 PSI. So when it lands, it bursts and we cement right through the middle of the plug. When the top plug lands, it is over. The job is displaced. This is what we use on long laterals in unconventional wells. We use this quite effectively. A key there is to make sure you clean the casing all the way out. When we complete the well, we don't have to want to circulate all of the debris out of the well. Dynamically settled barite or cement. And we would circulate a bunch of trash or a bunch of debris out of the well. When we went to using two bottom plugs and this top omega plug, a regular plug, but then a large wiping ball on top of it, we got very good results. Here's the cement head that we will put the plugs into, the top plug T and the bottom plug B. You can look down in that cement head and you can see our bottom plungers that will retract to release the plugs. So we have our top and bottom plug. We'll pump our spacer through this double plug container cement head. We'll then launch the bottom plug with cement, pump all of our cement for a production job. We'll wash pumping lines to make sure that we don't get too much cement on top of the production top plug. And then we'll displace and launch our top plug and displace until it bumps on the collar. Here are a couple of economic collars. You can see the shiny black noses of the check valve there. And we're going to land right on top of that and seal with the flat part of the plug. Oh, I've got John Clark's name here, but John Clark, I'm sure, is not on our late night. And so I'm going to do a new share. I want you to look at some new technology. This is from Vallant. I'll introduce it here. I think you can see that. Can you see the plug launcher? We kind of introduced cementing through the top drive. Many years ago, we used to cement through the top drive and we would drop the plugs by hand. And oh, do I have some stories to tell about the dangers of that, of dropping plugs by hand in the middle of a cement job. This is another way to, as we cement through the top drive, also with the casing running tool and with a swivel where we can quickly run the casing. We'll be able to rotate while we cement and we launch plugs. I think the only jobs for this plug launcher so far have been in Australia. The case histories are in Australia. There are other systems like this, but I wanted to present to you some new technology, and this kind of stuff to me, I like this quite a bit. And so let me show it to you. First of all, let me quiz you. Can you see on your screen the Vallant plug launcher? I don't want to show you it and then you tell me we don't see anything. Okay, great. I'll hit play. Let me first add a little sound and a little optimization, and away we will go. Okay, we'll just take a look. I think you'll be able to see it.
Well construction just got simpler. Improve your long-term well integrity and reduce the flat time between landing casing and cementing with the Vallant paddle valve plug launcher. Vallant's paddle valve plug launcher enables a worry-free plug release through its remote pneumatic control system. While in the ready-to-launch position, flow is diverted around the plugs through the tube bypass. When launched, the paddles drop, blocking the bypass and diverting flow to the top of the plug, ensuring a positive launch every time. A launch indicator is triggered by the passing plug and is reset from the pneumatic controls on the rig floor, while the interlock on the control panel ensures plugs are released in the correct sequence. When combined with a CRT and cement swivel, operations are further enhanced by achieving continuous rotation, reciprocation, and a more uniform cement distribution. Simplify operations and improve long-term well integrity with the revolutionary Vallant plug launcher.
The plug launcher and that sort of operation, again, we used similar type systems so that we could rotate, but that we could do things quickly. And I think you'll see more about this tool in the future, some of the case histories. Again, I have no relationship with Vallant, but I like this kind of technology. And I would state to anyone who has some new technologies during our webinars, you want me to if you're willing to let me show it, I know a lot of our participants want to see cutting edge and what's going on out in the field. So thank you to Vallant for allowing me to show that. The equipment. What are your top concerns with the cementing equipment? Your big concerns. I'm thinking when I was at Oxy and we talked about the whole equipment thing, I think of big concerns that always came up. What are your concerns with the cementing equipment from an operations standpoint? The big concerns. Okay. Mohammed says the float, and we're going to look at that a bit, but now we're looking at the casing equipment, which is cementing equipment. What about the actual pumping equipment? A good question about the plug launcher, and I'm not sure I have the answer to that, but at the end of the webinar, we're going to have, the question is there any frequency, how to maintain this plug launcher? And this is kind of the first I've seen, I'm just learning about that plug launcher, but I've got some information for you in regard to that. At the end of the webinar, we're going to have a question and answer session. And so bring that up again, if you could, at the end of the webinar. What about the cementing equipment, the pumping equipment I'm referring to? What about the pumping equipment? What are your concerns? Someone says, does it work? What are the pressures? Okay. Or what pressures or volumes? You might spell that out a little more. What are your concerns? I'm here. I've started up the equipment. I'm priming the pumps. We're getting ready to go. Will it pump continuously? Do I need a standby truck? Will this truck fail? That's always on our mind. Will I pump at the right rates? We have different plunger sizes that are rated for different rates and pressures. 3.5-inch plunger for high pressure situations. We have a 5-inch or 6-inch plunger, but a 5-inch plunger for higher rates, lower pressures. Complete this sentence for me. I want the cement unit to show up, you know. I saw a cartoon where someone was sitting on, I think he was sitting on the Eiffel Tower, and the snow was covering him, and someone asked what he was doing. He said he was waiting on, and then he named a service company. But we want, when we're ready, we want that cementing unit to be there. So that whole planning of when do you call the unit out without spending a lot of standby time, but the coordinating, I want to make sure that cement unit is there, but I don't want to be paying a lot of hours of standby. Obviously offshore, it's always there, and we maintain it offshore probably a whole lot better. But waiting on the cementing unit, I won't put a service company name in there. Will the unit break down? Do I need that standby unit? When we have so many sacks of cement, sometimes we'll recommend having that second unit there. I'm not sure when you need it or not. We don't have a second unit offshore, critical cementing. Need contingencies where the rig pump can quickly transfer to do displacement or circulate cement. Yep, exactly, Mohammed. Safety. We're always looking, making sure we pressure test, but making sure the lines are secure. We're looking at things. Do things look right and safe? We're looking for leaks. Safety is a big issue. For me, you know, you always think you're about 26 years old. So I go out to location, and I'm finding the 6th time I climb up some of these ladders on the cement units, I just stay up on the truck. I don't want to take that adventure. Do not take for granted the ease at which you climb onto a cementing unit at your young age. That has something to do with why we cemented up some mud tanks, okay? It's a long way the 6th time down to get off the truck and go over and supervise the cement returns. The cementing unit, here is our mixing tub on this particular unit. it will free fall, or more likely boosted with the centrifugal at about 40 to 50 psi to a suction manifold. That suction manifold will feed the plungers of this triplex pump and will pump it through the discharge line at high pressure. We will then, once we've pumped the cement, we've dropped those plugs, we'll now displace with the cementing unit or the rig pump. Offshore, it's usually the rig pump. On land, it's almost always the cementing unit. We'll measure that displacement, usually in 10-barrel containers. We'll fill one while we're pumping the other down. We'll be filling the other, and we're counting the barrels. We also have a counter with the drive shaft, a barrel counter, kind of like the strokes for a rig pump. And we're going to bump the plug. I kind of made a joke. Sometimes sense of humor does not work well. If you go to an SPE meeting, a serious SPE meeting, humor does not work at all. It has always failed me. Just go to an SPE meeting and be serious. Just the facts. But I kind of made a joke on LinkedIn. I said, can we bump the plug at 14 barrels per minute? And someone said, you cannot. You need to slow down. And we do need to slow down to bump the plug. But trust me, you can bump a plug at 14 barrels a minute. I know you can. It's an interesting thing to do. You don't want to do it, but you can. But we want to slow down to land that plug. We'll bump at 500 psi generally over circulating pressure and hold it for 5 minutes. We then will check the float. We have pressure trapped on the inside of the casing. From lifting the cement can now not come back in because of that check valve, but if the check valve fails, all of the displacement fluid will start flowing back. And so we'll check the float, it starts to flow, but then it stops and we are happy. If it doesn't stop and it starts to flow, we may let it flow strong and slam it shut and then open it again fast, trying to jar the float valve to seal. Something I do not do, now our floats have held, so we're good. But something I do not do when the floats haven't held, that everyone does, so everyone is probably right, but to re-bump that plug, we often just let that plug where it ended up to stay there. I never liked pumping back and perhaps bypassing plugs, and I just didn't like pumping back on a plug, but everyone does it and it's probably the right thing to do. I just never have. How much should you flow back? If you know your operation, you know exactly what you should flow back. In certain fields, every time. With water, we're going to get 5.5 barrels back. With compressibility factors, it's going to change with oil-based muds, different densities and pressures, but you can calculate that. Finally, the returns. We got everything pumped. While we're pumping though, we're watching returns. You may want cement returns to surface. They may not be part of the design. Either way, we're watching the returns. What are your top concerns with the returns? What are your big concerns? And we'll look at this and then we'll quickly look at cementing up the pipe and we will be finished. We've got about 13 more minutes left. So what are your concerns with the returns? How much cement did you get back? What are your concerns about the volume, Mohammed? You may want to know them, but what we want to know if we have cement returns, Nicole says. Natalie talks about knowing the density of the returns. When we have cement returns, our mud is being circulated into the mud pits. When we have cement returns, we direct it into a waste pit or a disposal tank or a waste tank. and we add sugar to it to keep it liquid, and we will dispose of that. We do not want the cement in the mud tanks. Even worse, with oil-based muds, we don't want the surfactant spacers contaminating and killing the good oil-based mud. So we need to know if we get cement returns to surface. Here are my concerns, and great comments, I appreciate it. The first thing with returns, cement or no cement, do we have lost circulation? Sometimes we can get fooled a bit because cement is falling fast. When we catch up to it, we stop getting returns. It goes back and forth. But we're always looking, are we getting returns? Do we have lost circulation? Objective of the job is to lift cement. Are we lifting cement? Another concern, did we get cement to surface? And was it 5 barrels? 5 barrels seems to be the magic number for the amount of returns that you get when you really didn't get returns. A concern that my boss used to have is, why are we pumping so much cement? We're getting back 200 barrels of cement. I want to get back 1 barrel of cement. I want to save that money. Well, we need to get some returns. We can't go for the 1 barrel. I don't like the number 5 barrels, but we don't want 200 barrels back either. When we're getting 200 barrels back, usually it's because of channeling, and that becomes a concern. So how do we know if it's channeling? How do we know how much cement we're getting back? We monitor those returns. And here we're getting flow from the return line, and we're starting to get cement returns. I don't know if you can see that, but it starts getting clabbered up quite often. You'll get a viscosity change, and you'll get a smell. Now, I can't smell very well, so I can smell it, but I really don't use my nose to look at cement returns. I know a company man who can smell cement from across the other side of location. He will tell you when you have returns if the wind is just right. He tells me it smells like bubble gum. We're getting cement returns. I was never good at that. But we can observe the appearance, a viscosity change, and a smell. I'll give you that. We can look at the pH. We use phenolphthalein, and we use it. It will indicate orange for an acid. Above 8.3, 8.5, it will indicate pink. The higher the pH, it will turn a darker purple with some sharp edges to it. You see some of the drilling muds are above 8.3 and will be pink. And so even using indicator, which we need to have on hand, very useful. We need to be able to recognize when it's cement returns. We also can weigh the densities. I have seen, once we start seeing cement returns, that it takes 50 to 100 barrels before the density starts even marching upwards, showing that we have channeling. And if you mark that, and then you can measure how much of displacement before we bump, you get a good idea of how much channeling that we're getting. So we can learn a lot from the returns by checking the density. We can also check the temperature of the returns. If we know the temperature in and the temperature out, we have great simulators that tells us what our true bottom hole circulating temperatures probably are, so that we can do a better job of designing the cement job. We can monitor the lift pressures, and the final lift pressure will give us an indication of where the cement probably is at. Returns, very important to monitor them. I'm going to close with talking about what we all do not want to talk about, and that is cementing up the casing. Last time I cemented up the casing, things were going so well on the job. I was actually in Kurdistan, and things were wonderful. It was a perfect cement job. Everything was going, and I remember walking, doing a safety walk, getting back on the truck thinking things are going a little too smooth. And of course, we ended up cementing up the entire liner. Here are the key reasons that I've experienced of why we flash set cement or we cement up the casing, which no one wants to do. Formation pack off is maybe the #1 reason that we cement up casings. The cement is often blamed, but often it's the formation pack off. Floats being plugged by LCM, the bottom plug not opening, we talked about that. Once you shut down, the cement may not want to start up again, so cement static too long. We talked about heat retention and cementing up batch mixers. Cement dehydrating in an air drilled hole happened to me in Adelaide area of Australia. In Southern Australia, we did not put fluid loss in a cement and we cemented drill pipe in the hole. Especially in the early horizontal wells, we would pick up the cuttings with spacers and at that interface and plug off at liner hangers. I'll show you a liner dart that stopped at the top of liner and we cemented up the entire liner. Cement contaminated and wrong cement blend. I'll just again say the formation pack off. We've seen open hole calipers that look like this. The longer the exposure, the more creep that comes in. Been involved in a lot of analysis of formation pack offs. Liner dart, take a look at this. The liner dart hit the top of the liner and the job was over. The liner dart was supposed to launch the liner plug and it did not. When we pulled out of the hole, this is what we found in the drill pipe. We found, in our running tool here, we see at the top of the liner, our plug got cocked there, our dart did, and landed on a ledge and it would not go any further. You can see here how it hit and even bent the way it was cocked. So we retrieved that liner dart, cemented up the entire liner. And then finally, cement contaminated. I talked about this story, the 1 in a million, where we went and picked up some contamination, but it can be contaminated in a lot of other ways. Offshore is one of the big ones of where the cement sits out there for a long time. It's contaminated with moisture. We fluff it ever so often and we inject more moisture into it. That's why we need to blend test, or as we sift, we get fines, or as we road the materials, maybe some of the additives, hollow spheres float out or vibrate out. I will close by just showing a couple videos of at the end of the job. In this case, after the job, the cement is flowing out of the well. The rig is already left. This occurred because the cement was mixed at the wrong density, never set up. This is a low pressure, low volume well. Eventually we had to re-cement this entire well. The cement just kept flowing out due to poor mixing. Here's one that I show quite often. I don't like this at all. Let's see if I can play it. It's our gas bubbling. Yep. What happened here, everything was fine. Everything was good until we started nippling down BOPs. And we had a cement that wasn't setting up very fast. We had a shallow gas zone. And when we nippled down BOPs, the stress on the casing, we started flowing gas between the cement and the casing. We fixed it, but ultimately to fix this, we ultimately had to abandon the well. So we lost $2 to $3 million because we nippled down BOPs too soon, basically. So even after the cement job is placed, there are operations. All of it ties in with the design to get the end result, and that is a nicely sealed well with good integrity. I'll summarize, and thank you so much for attending the webinar. I'll summarize by saying the local cementing practices are key. You need to establish what works for your region. You need to take global procedures and make them work locally. You have your own special considerations. It's attention to detail. The field personnel need to be trained. They need to be trained to pay attention to detail. And you need to partner with your service company. The oil company will have the knowledge and the procedures from the beginning to the end. Sometimes the cementing guys come right in there in the middle of it. You need to partner and work to do the procedures and the operations correctly. Well, thank you so much for attending the webinar. We'll have a time now for questions and answers. Thanks again.